Picture this. You're sitting in the exam hall. The clock is ticking down. You flip the page, and boom, there it is. Cambridge Biology AS and A Level 9700, Section 3.2, Effective Temperature on Enzyme Activity. Now, this is a topic that pops up in literally every single exam series. You probably think you know it backwards and forwards. You think, hey, it's just basic biology. But the harsh reality? This exact topic is where thousands of students accidentally bleed crucial marks and completely lose their grade boundaries every single year. Welcome to The Explainer. Today, we're taking a highly strategic, insider look at exactly what it takes to secure those top-tier marks. Let's get into it.
Okay, let's dive right into this. Read this with me. As temperature increases, enzyme activity goes up. Then, it gets too hot, and the enzyme dies. Now, if you've ever scribbled down something resembling this under the immense pressure of a timed exam, believe me, you are definitely not alone. It kind of sounds right, doesn't it? It feels like it captures the general vibe with the biology.
But here is the brutal reality check. That vague answer earns exactly 0 marks. Nothing. 0. And this is exactly why your standard, everyday memorization just completely falls flat in the exam hall. Cambridge examiners aren't looking for the general vibe of the science. They demand precise, rigorous terminology. If you're relying on conversational, everyday logic, you're going to miss out on the points entirely.
So how do we fix this? Well, we need to completely rebuild your theoretical foundation. Top-performing candidates don't just memorize a bunch of isolated facts. They build a solid core framework out of precise definitions and causal relationships. But here's the real secret sauce: cross-topic connections. The Cambridge Syllabus Guidelines and the Principal Examiner Reports consistently tell us that students who link the effect of temperature on enzymes to totally different areas of the syllabus, things like membrane structure or kinetic energy principles, well, those are the students demonstrating true transferable conceptual understanding. And that right there is what unlocks the highest grade bands.
You've really got to realize that when you're answering a question on 3.2, you aren't just being tested on your memory of enzymes, you are actually being evaluated across 3 distinct cognitive domains. First, your basic knowledge and understanding. Second, your ability to handle and evaluate complex information, like those really tricky graphs or dense data tables. And third, your experimental skills. The examiner is actively hunting for proof that you can think like a real scientist across all 3 of these objectives all at the exact same time.
Now, in just a moment, I'm going to show you the exact examiner clue that will completely change how you answer data questions. It's this tiny, easily missed detail that most students completely gloss over. But to actually spot it and to use it effectively, you first need to understand the procedural framework that makes the clues so obvious in the first place.
Let's move to and see how this builds a foolproof, standardized 5-step system for processing literally any temperature question. Step 1. Deconstruct the question. Step 2. Extract the stimulus data. Step 3. Select your analytical framework. Step 4. Execute with clear notation. And finally, Step 5. Present your answer with the correct terminology. If you follow these 5 steps, in this exact order every single time, you eliminate the panic and you force yourself to align perfectly with exactly what the examiner wants to see.
Okay, let's apply that framework right now. Take a look at this data. We've got temperature, rate of reaction in arbitrary units, and denaturation state. At 20 degrees, the rate is 15. At 37 degrees, it peaks at 45. But then at 60 degrees, it absolutely plummets to 5, and we see advanced denaturation. Your data interpretation skills here are absolutely critical. You have to extract that information, interpret the mathematical relationship, and be ready to draw evidence-based conclusions from it.
Now I want you to pause and predict for a second. Looking back at that data we just saw, the one showing the peak at 37 degrees and the massive crash at 60 degrees, can you spot the critical error in how a stressed-out student might analyze that specific scenario in a free response question? What is the one thing examiners absolutely hate seeing the most when students interpret this exact setup?
And this brilliantly illustrates the difference between an average student and an elite candidate. Just look at the average response on the left. The rate is highest at 37 degrees and then drops because of heat. It's so vague, right? It lacks data. It completely lacks terminology. Now compare that to the elite candidate's response over on the right. The optimum temperature is 37 degrees Celsius at 45 arbitrary units. At 60 degrees Celsius, the rate decreases to 5 arbitrary units due to denaturation of the active site. See the difference? The right side uses specific data points. It uses the phrase optimum temperature instead of just saying highest, and crucially, it names the active site rather than just vaguely stating the enzyme dies. This is exactly how you secure those marks.
When the data requires you to compare things, you must treat these rules like your ultimate cheat codes. Higher-order assessment objectives demand that you truly evaluate alternatives. You must identify both similarities and differences. You have to use proper comparative connectives, words like whereas or conversely. You must support every single comparison with hard data extracted directly from the table or graph. And finally, you must draw a conclusion on their relative importance. You're not just making a list of facts here, you're actively evaluating the evidence.
Which brings us to a massive examiner alert. Please, whatever you do, burn this quote into your memory. Even if your final answer is completely wrong, method marks can save you. Always, always show you're working. When you're calculating rates of reaction or figuring out percentage changes in enzyme activity based on temperature, you absolutely must write down your steps. The method mark strategy is very, very real. Examiners are explicitly instructed to award points for your process. Even if you make a silly calculator error at the very last second, do not leave those marks on the table.
So the crucial point here is knowing exactly what trips up thousands of other students so you don't make the same mistakes. We analyzed the principal examiner reports, and these are the top 3 consistent warnings. Number 1, answers are simply too vague. Saying it gets hot is useless. You need to say increased kinetic energy leads to more frequent successful collisions. Number 2, forgetting to check units. If the graph says arbitrary units, you better write AU. And number 3, failing to make answers specific to the given context. If the question is about a specific enzyme in a hot spring bacterium, your answer must reflect that highly specific context, not just standard human body temperature.
To truly break into those top-grade boundaries, you must demonstrate evaluative thinking. It's not just about describing the curve on a piece of paper. You need to question the underlying assumptions made in the experiment. Were all the other variables actually controlled? What are the alternative interpretations of the data? What are the limitations of measuring enzyme activity in this specific way? The top-scoring candidates always justify their decisions by stepping back and evaluating the actual quality of the evidence itself.
Let's lock this all in with a quick memory hack recap. Whenever you face a 3.2 temperature and enzyme question, just remember these 4 pillars. 1. Master causal relationships. Temperature affects kinetic energy, which affects collisions, which ultimately affects the active site. 2. Extract and calculate your data accurately. 3. Show every single step of your working to secure those lifesaver method marks. And 4. Use precise, examiner-approved terminology. Remember, no more writing, the enzyme dies. You'll now have the exact framework for analyzing the data, structuring your response perfectly, and securing every possible method mark. But here is the real diagnostic cliffhanger. What happens when you perfectly apply absolutely everything we just talked about, but you completely misinterpret a single command word in the exam prompt? If the examiner asks you to evaluate and you only explain, you're going to lose more than half the marks for that question, and it won't matter how good your science actually is. The hidden cause of most lost marks isn't a lack of knowledge at all, it's a failure to decode those specific command words. So, to map your new framework to Cambridge's highly specific language, make sure you're subscribed to Ace the Exams and jump right into our next explainer immediately so you can fully secure your grade band. I'll see you over there.